A rod PQ of mass m and length L is hinged at MP. The rod is kept horizontal by a massless string tied to point Q as shown in the figure. What is the initial angular acceleration of the rod when the string is cut? To find the initial angular acceleration of the rod when the string is cut, let's analyze the situation. The weight of the rod, mg, acts at its center of mass, which is located at a distance L by 2 from the hinge point P. This creates a torque about point P, which is given by tau is equal to mg L by 2. The moment of inertia of a rod of length L and mass m about an endpoint P is given by I is equal to 1 by 3 ml square. Using Newton's second law for rotation, tau is equal to I alpha, where alpha is the angular acceleration, we get mg into L by 2 is equal to 1 by 3 ml squared into alpha. Now solving for alpha, we get alpha is equal to mg L by 2 divided by 1 by t ml squared. Further solving, we get 3g by 2l. Therefore, initial angular acceleration of the rod is 3g by 2l, which corresponds to option D.